Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4, Section 5. Today we present to you about steel truss design of a stadium. Okay, first of all, my name is Muhammad Azri bin Zamdin. I will explain to you about introduction. Okay, for the background, structural steel is a common building material that is frequently used in conjunction with concrete to produce stunning and long-lasting structures. The total allocation for this project will be approximately 70 million ringgit, which will begin in February 2023 and expected will be fully completed by June 2024. The size of this new basketball stadium is square feet and the court size is 10.7 meter times 20 meter. Besides, it will be able to accommodate up to 1,000 spectators with premium VIP and official seat. For the next slide is illustrated of proposed design. This is a design for our basketball stadium, and beside this is project detail. The project title is Basketball Stadium in Georgetown, Penang. The location is in Georgetown, Penang. Developer is Four Guys Sdn Bhd. Consultancy for architecture is Marvel Architects Sdn Bhd, and consultancy for civil and structure is Captain Construction Sdn Bhd. The construction period will be around February 2023 to June 2024, and the construction fees is 17 million ringgit. Next, for the truss design, a truss often known as an open web girder is a triangulated structure of straight interconnected structural parts. The different pieces are joined together at node and it is frequently considered that these connections are formally pinned. Space truss can be determined when it contrasts to planar trusses. The members and node are positioned in three dimensions. And for the form of truss, the shape of truss that is chosen is hoe truss. A hoe truss is the type of truss bridge made up of chords, vertical and diagonal, with the vertical member in tension and the diagonal element in compression. As a result of the longer diagonal members, the hoe truss required less of the more expensive iron material. Next, for the engineering judgment, as for the truss member, two main components involved, which are the rafter and the purlin. Rafter are wood beam that incline upward from the ground. Purlin is a horizontal beam or bar that is used for structural support in building, most commonly below the roof, where purlin are held up by the rafter or the wall of the building. As for the dimension of the members, the total length of the top chord is 28 meters, with the distance of purlin 2 meters.
Assalamualaikum, my name is Nalai bin Chandraza and my number matrix is TF200144. So I would like to explain about design overview for chapter 2 in our project. So in this chapter, all the drawings involved are simplified without changing the existing design. And then this chapter aims to make designing works easier, and all dimensions and sizes are also shown clearly. And among the drawing involved are the truss structure drawing, side view, front view of the building, and all dimensions are in meters. So as you can see on the slide, there are a simplified layout for structure of the truss, detail of the truss, the front view of the stadium, and the side view of the stadium. So for the next slide, I will explain about the load computation. So the proper computation of load is very critical in the process of constructing steel stadium to ensure the structural integrity and the resilience of the entire stadium. And then as a future engineers, we can construct a design that can safely handle the forces imposed on the stadium by carefully assessing and integrating different sort of loads, offering a secure and durable environment for fans and athlete alike. So as you can see on the slide, it is a list of QK, GK, and WK, and also references from BC and BS. Next, I will explain about the design wind pressure, which is simple part procedure. So steel is frequently employed in structural engineering for its strength and endurance in the construction of magnificent structures such as skyscrapers and bridges. However, considering the impact of wind on these buildings, it's critical to ensuring their safety and stability. So the design wind load is very important component in steel design because it helps and establish the proper dimension and material required to withstand the wind pressure. So the formula for wind load as we can see on the slide, and the AVS is 32.5 M per second. We choose zone 2 because our building is located in Penang. So for the P MZ cat for terrain category C, so we get the uplift equal to 0.888 kN over meter square. For the CPE for downwind slope, negative 0.6 we're using interpolation, hence we get the W download equal to 0.856 kN per meter square. I will continue to the load cases. So the load cases are diverse scenarios or conditions that subject to a structure to various forms of loads. So wind, snow, earthquake, and even the weight of people and items are an example of loads. So each load case reflects a unique combination of these forces and aids engineer in understanding and how structure will respond in various scenario. So as we can see on the slide, we already stated the value of GK, QK, S, W, and W as we already calculated earlier. And then the summary of the load combination, we put it on the table as we can see on the slide. For 6.1 and 6.1, 6.10A, 6.10B have a different types of formula, and then we stated in the table as we can see. We're moving on to the next, which is the choice of truss shape and dimension. So we were agreeing to choose double hole truss because it is a truss that due to several factors such as cost efficiency, durability, and it also has a great weight of distribution. And then our truss is also a cost-effective truss system partly because it is a very simple design with equal angle that makes it simple to build and to calculate. And then the majority of the truss member in the design probably act in compression and tension, thus it will resulting in the high durability. The last slide of me is which I'm gonna talk about connection time. We decided to choose welding connection because welding connection usually using materials joining parts in which two or more pieces which are welded at their contacting surfaces by applying heat or pressure to the contracting surfaces. And then as you can see on the slide, these are the welded connection proposed in the project. And then the welded connection which will be used is a direct shear because it securely holds the structural components together in this connection. And then for the joint configuration, the welding connection are frequently selected in the buildings that are demand great strength and durability because they can be enormous loads and provide long-lasting performance. That's all for me. Thank you.
So Assalamualaikum, my name is Muhammad Kamal, number matric BF44903. So now we will continue the presentation about the chapter 3, which is determination of internal force. So for this chapter, we use two methods, which is the first one would be hand calculation, and then the second one will be stat rows of analysis. So what do we need to do first? First, we need to analyze the load transferred by using hand calculation. So after we have made the calculation, the data of load that we have achieved will also be used for the stat rows of analysis, and then we will get the internal force for each members in this project. So for the hand calculation, we use the alternative method because we find it more easier to use rather than method of join, because method of join is more complex and we will tend to make small mistake that will affect all the project. So by using alternative method, it is more accurate, and I will show you on the next slide. Thank you. So after we have made a careful calculation by using hand calculation and also stat rows of analysis, we can identify the internal force for each member. So we can find here that the range of difference would be 0% to 3.3% only, which means that our hand calculation is almost similar to stat rows of analysis. The left one that I made is the top 5 lowest percentage of difference, which is from 0% to 0.5%, while on the right table is indicating the top 5 highest, which is 8.5% to 3.3%. So all of this percentage difference are below 10%, which means that our calculation is acceptable to be proceed to other calculations.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Abu Hafizuddin. I will continue to present about the design critical tension and compression member. First of all, we must select 5 most critical compression member and 5 most critical tension from the manual calculation. And then, as you can see in the table, these are the selected members that we want to design. Okay, this is the example to design the critical tension member. The member that we use is NO. First of all, we calculate the value of area by using the equation NTRD. After we got the answer, we must refer to the table of properties and select the suitable size of member. So we decide to use 200 multiply 150 multiply 12. Next, we calculate the value of NURD and we will compare it to the value of NED. And then after that, the answer is less than 1.0. So the design is okay. Okay, next is the calculation to design the critical compression. First of all, we calculate the classification and the answer that we got is class 1 for overall cross section. Then the value of design buckling resistance are calculated to compare with NED, the value of NED. As you can see, this all the calculation and step to get the value of design buckling resistance. The final value that we got is less than 1.0 and the design is okay to be proceeded. We continue to the reflection part. This part will explain about what are the problems that we have faced and what we achieved in doing this project. The first one is research and selection of design. We encountered some challenges in finding a suitable stadium drawing design. The drawing were either too complicated or lack sufficient information. The second is about all the assumptions that we use. We initially faced difficulties in determining the value of the assumption. However, after asking for help and learning from others, we were able to find out how to determine the assumption values that need to be referred in EC3 and EC0 and National Annex. The next is calculation and design. Although we faced the challenge of getting the smallest difference value compared to Step Pro, we were able to get values close to Step Pro values. We also successfully divided tasks fairly among group members. And lastly, software usage. We were able to successfully relearn how to use AutoCAD and Step Pro, and we are now able to explore various things in this both software.
Assalamualaikum and hi, my name is Isleka binti Jamil with number metric DF200145. So today I will continue their presentation with explaining their design connection. So firstly, welded connections are commonly utilized as rigid connectors in steel frame beam to column connections. So it is required in the construction of steel structures. Good design results in cost-effective fabrications that can be built to needed standards through the use of coordinated specifications that allow for quantitative control of work quantity. Welded connections also are those in which the components are principally linked together by weld. Next, I will proceed with the design connection calculation. So this calculation is using the direct shear method. So as you can see, the first one, the YP is 94.8 millimeter, meanwhile for the YP is 55.2 millimeter. So the load for one angle section, which is FWED, is 15.35 kilonewton. So the first calculation, which is the design shear strength of weld, FVWD, is 222.79 Newton per millimeter square. And secondly, the design resistance of the weld per unit length is obtained as 935.72 Newton per millimeter, which is 0.936 kilonewton per millimeter. Proceed with the next calculation. So the minimum length required is 16 millimeter, and in weld length it can be arranged in two ways. So we chose the balance the weld on each side. So in this calculation, the required length is 22.11 millimeter. So we choose the 25 millimeter of length instead, and for the other side of length, the required length is 17.89 millimeter, and we chose 20 millimeter instead. So below are the illustration of our sketch for the welded connections that has been calculated. So that's all from me. Thank you.
So, for the conclusion of this project explored the design and analysis of steel truss stadium using hand calculation and also the StatPro software analysis to find the internal member of the horse. Secondly, the design of steel truss using equation is very complex and time-consuming, so computer software programs are used to design and analyze these type of trusses. The connection acts as the medium of load transmission from the roof to the column, and by performing this project, our group are able to design a steel structure for the basketball stadium and gain more exposure to real-world engineering situation. For the recommendation, different computer software programs can be used to design and analyze the process for stadium such as Midas Civil, RISA 3D, and SkySafe Structural 3D to save more time. To be functional, the truss must be cost efficient to be installed and should not require heavy, expensive equipment or extensive preparation. Steel trusses must be strong, and they might be more cost effective than beams or long span. Economical stadium design is also important to maintain the existing stadium design to save costs of repairs and restoration work in the future. And that is all from our group. Thank you very much for watching, and Assalamu alaikum.